Hello everyone, welcome to our webinar today. This is Shabaz. I'm a product manager in the Azure Network Security Customer Experience Engineering team here at Microsoft. Today we'll be talking about what's new in Azure Web Application Firewall. So here's the agenda for today's session. We'll start with Azure WAF Overview, and then we'll cover some of the newly released features for Azure WAF. And then my colleague Andrew will be demonstrating some of these features. And finally, we'll spend some time on Q&A. So let's get started. So let's begin with Azure WAF Overview. So before diving into the Azure WAF itself, let's take a look at some common web application attacks that we face today. These attacks can broadly be categorized into three types. Firstly, we have the distributed denial of service attacks, also known as DDoS attacks, that overwhelm web applications by flooding them with massive amounts of traffic, aiming to disrupt service availability. So Azure's DDoS protection combined with Azure WAF provides a layered defense by filtering malicious traffic and ensuring that legitimate users maintain access. So examples of these attacks include TCP floods, HTTP floods, etc. Beyond the DDoS attacks, we also have the targeted web application attacks that exploit vulnerabilities such as SQL injection, cross-site scripting, OS command injection, and remote file inclusions. So these attacks manipulate or inject harmful code to compromise the application or its data. And lastly, we have the malicious bots, which pose continuous threats by automating activities like content scraping, credential stuffing, probing for weaknesses, etc. So these bots can cause financial loss, damage SEO rankings, and even deliver malware. So protecting against these diverse attacks is really important, and that is where the Azure WAF comes into the picture. Now let's take a look at the Azure WAF. So Azure WAF is a fully managed cloud-native security service designed to protect web applications from a wide array of common threats and vulnerabilities. As a platform managed service, it eliminates the operational overhead and it can eliminate the overhead of applying updates, scaling capacity, etc. So this ease of deployment allows organizations of any size, like from startups to global enterprises, to quickly secure their applications with high availability, scalability, and low latency. So Azure WAF can protect apps hosted anywhere, whether in Azure, on-premises, or in other cloud environments, making it highly flexible for hybrid and multi-cloud strategies. So it integrates at two levels, globally via the Azure Front Door for edge space protection, and regional protection with Azure Application Gateway. So backed by Microsoft Threat Intelligence, Azure WAF is continuously updated to combat new and emerging threats while meeting rigorous compliance standards that are critical for regulated industries. A bit about the key features of Azure WAF. So Azure WAF offers a comprehensive feature set tailored to provide robust and intelligent web application protection. It comes pre-configured with rules addressing the OWASP top 10 threat categories, effectively blocking threats such as SQL injection, cross-site scripting, remote file inclusion, etc. One of the key strengths is its bot protection capability, which is powered by Microsoft Global Threat Intelligence. It enables real-time detection and blocks malicious bots involved in activities like scraping and credential stuffing. Additionally, Azure WAF supports conditional rate limiting, which helps mitigate layer 7 DDoS attacks by throttling high volume requests based on client IP or geolocation. There are also custom rules engine, which these rules allow granular control by letting you define rules based on HTTP parameters, size restrictions, geo-filtering, and IP restrictions. And on top of this, Azure WAF provides detailed logging and integrates seamlessly with Microsoft Sentinel, which is the cloud-native SIEM solution for Azure. This enables automated threat detection and response workflows. Moving on, let's look at what are the new features that we have in Azure WAF. The first one is the inspection limit and size enforcement. So basically, Azure WAF provides flexible controls over how deeply it inspects incoming requests to balance security with performance. You can enable or disable the request body inspection and specify a maximum size limit for this inspection to avoid unnecessary overhead. Similarly, the WAF can enforce upper limits on the size of request bodies and also file uploads. These settings are particularly important to defend against attacks that use large payloads to insert malicious code or overwhelm application resources. By tailoring inspection depth and enforcing size constraints, Azure WAF allows organizations to optimize security while maintaining application responsiveness. So if you look at the slide here, there's old configuration, also new configuration. Previously, we only had a single place of enforcement where we can enforce the request body inspection along with the request body size and upload size. But in the new configuration, we can independently configure all these three aspects separately. So that gives us more control over the configuration. Now, the next feature that we wanted to talk about is the bot manager rule set. The latest bot manager rule set version 1.1 integrated with Azure WAF leverages Microsoft's continuously updated threat intelligence feed to provide precise bot detection and mitigation. The rule set is structured into three key groups. The first one is the bad bots group. So this group restricts malicious bots with behaviors such as scraping, credential stuffing, and vulnerability scanning, blocking them before they can impact the application. On the other hand, there's the good bots group, which allows legitimate bots, including popular search engine crawlers, preserving SEO and analytics integrity. The last one is the unknown bots group. This one will flag bots that don't clearly fit into good or bad categories, allowing administrators to decide how to handle these based on their risk tolerance. We can also configure rule actions like allow, log, block, or challenge via JavaScript or CAPTCHA to effectively differentiate between legitimate users and malicious bots. Recent updates further improve detection accuracy by adding new rules for good bots and bad bots, enhancing SEO performance and protection against scraping and denial of inventory attacks. So these are some of the rules that come with the bot manager rule set 1.1. Moving on, the next feature we have is the JavaScript challenge. So nearly 47.4% of internet traffic comes from bots, out of which 30% are bad bots. So the Azure WAF addresses this through the JavaScript challenge, a non-interactive mechanism designed to distinguish legitimate users from simple bad bots. When a client initiates a request, the JS challenge displays a challenge page momentarily as the browser computes the challenge in the background. This occurs automatically without requiring user interaction. So this is the challenge that we see on the browser. So we don't have to do any manual interaction here. If the computation succeeds, Azure WAF recognizes the client as legitimate and applies the rest of the WAF rules, whereas the requests that fail to complete the challenge are blocked, thereby preventing basic bots from abusing the application. This approach secures apps from automated threats while maintaining a seamless experience for genuine users. Moving on, the next feature or topic is the paranoia levels for WAF rule sets. Paranoia levels in Azure WAF define the aggressiveness of inspection and blocking rules to provide a balanced and customizable security posture. So each rule in the OWASP core rule set and Azure's default rule set, the DRS, has an associated paranoia level for that particular rule. So PL1 includes like foundational rules that are safe for most environments, detecting common attacks without blocking legitimate traffic. Whereas the PL2, which is the paranoia level 2, adds more stringent rules to catch edge case threats, but with a higher risk of false positives. By default, the WAF enables both PL1 and PL2 rules, but organizations can start with PL1 only to minimize false positives and progressively enable PL2 later on a need basis after monitoring and testing. So thereby they can reduce the false positives in their environment. So this tuning capability enables adaptable protection aligned with the risk tolerance in the environment. Now moving on, the next feature we have is the CAPTCHA for Azure Front Door WAF. So with modern web applications facing increasingly sophisticated threats, such as bots, web scrapers, brute force attacks that can bypass conventional controls like IP blocking and rate limiting, Azure Front Door WAF includes an interactive CAPTCHA challenge. So this mechanism requires users to complete visual or audio puzzles to verify their authenticity, effectively blocking automated malicious traffic in real time. So CAPTCHA is a valuable tool for preventing automated account creation, mitigating account takeover attacks, blocking brute force login attempts, stopping web scraping, and more. The policy settings allow administrators to configure how long a successful CAPTCHA validation lasts before running a new challenge. So balancing security with user convenience there. So this ensures that genuine users can continue interacting with the application smoothly while threats are effectively blocked. So this is just a snapshot of what kind of CAPTCHA challenge that the users will be seeing on the browser. Now, moving on, the next one is the WAF integration with Security Copilot. So Azure WAF's integration with Security Copilot brings advanced AI-driven capabilities to security teams, enhancing their ability to rapidly analyze threats and optimize defenses. The Security Copilot provides proactive threat analysis by uncovering attack patterns and identifying new threats early in the process. So during incident response, the Security Copilot capabilities accelerate investigations by delivering contextual information, such as the top WAF rules triggered, the most malicious IP addresses targeting in the environment, and details of significant attacks like SQL injection and cross-site scripting. So this is all done with the help of a simple natural language prompts in the Security Copilot portal. So we don't have to have a lot of knowledge of the KQL queries there. So this integrations streamlines operational workflows, improving overall security posture and response times. Now, the next one on the list is the WAF and Application Gateway for Containers. So Application Gateway for Containers is Azure's next generation layer 7 load balancer, tailored for Kubernetes workloads running on AKS clusters. This is now in public preview. It supports Azure WAF, extending robust web application protection to containerized environments. WAF on Application Gateway Containers provides protection against web-based attacks, including SQL injection, cross-site scripting, and protocol anomalies with the help of Azure's managed DRS rule set, bot managed rules, and custom rules. WAF policies can be applied at the listener level or to the specified routes, giving you the precise control over how and where security is enforced. We have a detailed blog on this topic in our Microsoft Tech Community blogs. It is highly recommended to check that one out to understand the setup and configuration of this solution. For all the other features also that we've just talked about, we have blogs published on them. So please check out our Microsoft Tech Community blogs. Now, moving on, the last feature that I wanted to talk about is the custom WAF block status and custom body for App Gateway. So by default, WAF block requests return a 403 status code with the generic "the request is blocked" message. The new feature allows administrators to define both custom HTTP status codes and tailored response bodies at the policy level, ensuring all block traffic receives consistent, meaningful feedback aligned with the application needs. So supported custom status codes include common HTTP errors and custom codes, and the response bodies can be up to 32 KB in size, providing ample space for explanatory messages or instructions. So this flexibility improves error handling and enables better alignment with organizational standards or legal requirements. So this is a snapshot of how you can configure it. You can provide the status code and provide the message that you would want to showcase to the users. So these are some of the new features of Azure WAF. With that, I would like to hand it over to Andrew to demonstrate some of these features. Andrew, the floor is yours.
Thank you, Shabaz, for that overview. So allow me to share my screen. Please let me know if you're able to see my screen. So if I'm audible enough. Thank you for the confirmation. So my name is Andrew. I'll be doing the demo part, showing some of the features that Shabaz has showcased. So these are the new features in Azure WAF. Some of them have been with us for almost a year. So we are covering the ones that we had not gone through in previous webinars. So to start us off, I'll begin with Azure WAF in Application Gateway. I'll go through the new features that came out in the past 1 year, as well as recent releases. So you can see here, I'm in the overview page of my application gateway WAF policy. The first place I'm going to begin with is in the policy settings. So within the policy settings, this is where we're able to see the size enforcements as well as the request body inspection features. So this came out last year in April, and what it allowed us is to have the ability to separate how we're able to inspect our bodies as well as enforce the body limits and the upload limits. So before this, as we also saw, Shabaz had shown us, is that before this, once you put on the enforce request body inspection, it also put on, or it also allowed us to do the request body limit and the file upload limit. So that means all these were intertwined together. You could not be able to separate them or to activate them separately, as is the case. So this has come about due to the feedback received, and it now also gives us more flexibility and granularity on how we are able to treat our inspection limits as well as our size limits on the request body and on the file upload. So this means, for example, if I only want maybe to inspect my body, but I don't want to enforce any request body limits or file upload limits, I can be able to do so independently of these two. And the same applies for the request body limit as well as for the file upload limit. So this really enhances the granularity and also gives us the control in terms of our limits, also in terms of latency. For example, maybe you just want to be checking on the request body limits, file upload limits, but leave out request body inspection. So this was an enhancement that came out last year. You can also see down here a bit, this is related to another new feature that came out. Actually, it came out this week, and this is for the custom response status code and the custom block response body. So previously, by default, whenever Azure WAF in application gateway did a block, you'd get a response code of 43, and then it would have the default template of the application gateway WAF when that block occurred. So what this allows us to do is actually customize these values, and also, and of course, with that, we're able to have our own custom message or custom banner depending on the organization, and also in terms of how the application will respond. Just to note on this one, they're actually pre-allowed values, so we can't put any value. You can see here, these are the supported values for the custom status response code. So 200 up to the rest. So this will be the ones that are supported. So again, this one gives us that ability to customize the response code as well as the response within the body that the user will get. So this actually came out a few days back, and we'll also see a quick example of it, how it actually looks like. So while we're still within these policy settings, I'm going to finish off with the JavaScript challenge. Like we saw, this challenge assists us to distinguish between legitimate users and illegitimate users. So extremely useful in identifying and stopping bots, of which there are a majority in the internet. So this also was released last year, both in Application Gateway WAF and Azure Front Door WAF, and it's in public preview. So within the policy settings, this is where we're able to set the cookie validity lifetime of that JavaScript challenge. This ranges from the minimum of 5 minutes up to an entire day. So having taken a look at the policy settings, we've seen these enhancements that came about. Next, I'll go to our managed rules. Within the managed rules, what we're going to take a look at or focus on is the bot manager rule set. And the latest rule set, like we saw, is the bot manager rule set 1.1. So this was also released last year. And what it did, it came about with various enhancements to optimize security coverage, as well as have expanded security coverage, being able to identify more bad bots, as well as new categories for good bots. In addition to that, this new bot manager rule set 1.1 assists in reducing false positives. So you can see here, this is how the rule set looks like. Within this rule set, we can see various rules. So these rules cover the categories we saw, the good bots, the bad bots, as well as the unknown bots. So in terms of the enhancements that came about, we had this rule 100-200 being added in the bad bots category. So this increased coverage for identifying malicious bots. We also had an addition of new good bot rules, and this ranged from 200, 300 to 200, 700. So what this did essentially is increase the coverage of well-known good bots, such as Bing bots, search engine bots, and of course, this would allow them to go through. In addition to this, we can also see within these rules the action column, and within the action column, we can set the specific action that is to be taken by a particular rule. So in terms of the action, if, for example, I select this, I'm able to change the action to allow anomaly score log block, as well as a JavaScript challenge. So you can actually have a JS challenge within an action within these rules. And in our case, we can see we set this action here for the last rule. So this is the new bot manager rule set 1.1, available in both Application Gateway WAF and Azure Front Door WAF. Moving on, we'll quickly take a look at our custom rules. And within our custom rules, we'll see our various rules that have been configured. Of importance to us that we want to showcase is actually the JavaScript challenge. Like we mentioned, the JS challenge, we use it to distinguish between legitimate users and illegitimate users. So this is non-interactive, invisible challenge. It won't require any human intervention. So in our case, we've configured a JavaScript challenge custom rule, and we'll see how it looks like. So it's a match rule type, and we've configured it to be on our request URI. That's on the match variable. And then it will match the value of /FTP. And down here, you can see we've selected the action as JS challenge. So what you want to do is just quickly demonstrate how this JS challenge is going to work. So behind this application gateway that has this WAF policy, we have a web application that is running. In our case, this is the application that we usually do for demos. It's called OWASP Juice Shop. And within this one of these pages, About Us page, you'll see this link here. And this link actually has a URI of /FTP. And if you've seen in our custom rule, this is where we want to match and have JavaScript challenge running. So what I'm going to do, I'm just quickly going to click on this link. And then I've also opened my developer tool, so we're able to see what happens in the background. We'll see the JavaScript challenge running. So that was it momentarily. Then when we go to within our developer tools, if I scroll down to my response headers, let me just expand this a bit. You'll see here under the cookie, we have this JavaScript challenge cookie. So it's the one starting with app gateway Azure WAF JS clearance. So this means that my browser, my agent is legitimate. It has successfully passed the JavaScript challenge, and it has now been allowed to go through. That's why I'm able to see this page. So this is the JavaScript challenge in action, just a simple demo to showcase that. Secondly, while I'm still within my application, I wanted to quickly show us how the custom response code and body works. So within my same page, on this next tab, I've already opened it. What I'm going to do, I'm just quickly going to do a very simple path traversal attack. And here you can see we have a 403 access denied. And this was actually set, if I go back to my policy settings, what I had shown us earlier, I'd set up the custom response code 994. Within the response body, I'd set up a simple HTML to show us this. So previously what you'd have seen, you just have seen application gateway v2 has blocked this, but now we're able to customize this. So depending on your use case, on your organization, you can put in a message maybe to redirect your users, tell them why they were blocked. Now this is also now available in App Gateway WAF. This was just to mention already available in WAF in Azure front door. And here within my response, you can already see the status. The code that we got is the 994, which I had set up here. So I just wanted also to demonstrate how that custom response code and the custom response within the body might look like. So moving on, so you've seen those features, the new separation of the inspection and the body limits, the JavaScript challenge, and also seen, of course, this response code. So what we're going to do is just take a look at the WAF logs in Application Gateway. So all these events, they're available within our logs. If you have set up diagnostic logging in your Application Gateway or Azure front door, you're able to query them and be able to see exactly the events that are going on. So for example, if I run this log here where we are looking for action as JavaScript challenge, we should be able to see specifically for JS challenge what has happened. So what I'm going to do, I'm searching within the last 12 hours, and based on my time range, you can see here this JS challenge, the first two logs, they're actually hitting my rule ID JavaScript challenge. That's my custom rule that I've configured for it. And here under the message, we can see that the challenge was issued due to a missing challenge clearance. So it didn't have, it hadn't run a JS challenge before. And then once it was passed, you can see the message. So with this, we are able, of course, to monitor our events. And also, like we saw, we had the JS challenge action within our bot manager rule set. And here you can see specifically in this particular rule set version 1.1 and the rule ID 300-700, where we have put action as JS challenge, that indeed JS challenge is running. It is issuing the challenge. But of course, if this, for example, is an automated bot that's unable to solve the challenge, it is going to be blocked. So you are able to monitor events for the JS challenge, and also if you have JS challenge within our Microsoft Bot Manager rule set. Great. So having taken a look at those features, next we are going to go to our Azure Front Door WAF. And here what we are going to do, we are going to basically just go through an overview of AFD WAF, also highlighting the new features and more so related to capture. So I'll start off with our policy settings. Similar like you've seen in Application Gateway WAF, you'll have enable request body inspection. Here, the difference is we have can also redirect traffic. You'll have a redirect URL. So that means, for example, if you set up a custom rule with action of redirect, this is where it is going to be redirected to. Within FD WAF policy settings, we don't have the separation of the request body inspection and the limits. But of importance to us is this feature down here, and this is the capture. So with capture, similar to JS challenge, we are trying to block. We are preventing legitimate users, automated scripts, malicious bots from accessing our web application. And the main difference, and also a question that we usually get, what's the difference between CAPTCHA and just challenge? So the main difference is, of course, in terms of the interactive mechanism. CAPTCHA, we'll see in the next section that it is interactive. That means the user actually has to click on something. They have to solve a puzzle or listen to an audio before they're allowed to proceed to the web application. So with this, it has various use cases. You can use it, for example, in your sensitive login forms, that is form submissions. You can use it in account creation or in password resets. Within now the policy settings, this is where we set the CAPTCHA expiration. You can set it in minutes, and you can set it between 5 minutes to 1440 minutes, which is an entire day. Similar to JS challenge for CAPTCHA, you can also use it as an action within your bot manager rules and also within your custom rules. So if I go here to my managed rules, we should be able to see our bot manager rule set, which we've also set to 1.1, as well as our default rule set. So bot manager 1.1, this is also available AFD WAF, similar to application gateway WAF. We'll have the same set of rules, and also within our actions, this is where we can be able to set what the rule does when there's a particular match. You can see some of these rules have been set to block. We have several allow rules. We have log as an action, as well as CAPTCHA. So we've set CAPTCHA as an action within our last rule. When we go to our custom rules, we'll see here we have a custom rule for CAPTCHA. I'm also going to take a look at it. So similar to what we saw earlier, it's a match rule. We are matching on a request URI, and specifically we are looking for these values within our URI. Of importance here is that we've set the action to CAPTCHA. So to demonstrate this, what we have is a simple web application running behind this front door. And this front door we know has this WAF policy attached to it. So here we are looking for these values, and I'm going to go to that particular web application. So you can see it's a simple app. We have two URLs, and this is for a particular organization. In our case, it's called the Contoso Static Cake Shop. So we have set up a CAPTCHA, and specifically we want to ensure that when our users go to a particular URL or link within this page, they actually are presented with the CAPTCHA, so they are able to validate that they are a legitimate user. We also opened our web developer tool, so you can be able to see what's happening in the background. So I'm going to click on this second link, which is called Go to Checkout, and it is supposed to bring us the CAPTCHA. Let me just load this again. And this is actually our CAPTCHA puzzle. So here it's telling us security verification. Please solve a puzzle so that you know you're not a bot. Just to mention, we have two options. We have this click puzzle, which basically means I can start this, or I can also switch to an audio puzzle. So I'll listen to an audio and I'll be able now to answer based on those audio instructions. So what I'm going to do, I'm actually going to use the first option. And in my case, it's just asking me to move the train icon indicated in the left image. So this is the train icon. I hope you can be able to see it in blue. And I'm supposed to match this image. So if my eyesight is good and I'm able to find the image, I'm going to align it, and then I'm going to submit. And with that, we've been able to pass our CAPTCHA challenge. And now we are going to our checkout page. I'm going to also go to within our headers, where we're also able to see the captcha cookie that we have received. So that means I successfully passed this and I received the cookie, so I'm able to proceed. So this we also have a very good mechanism method for distinguishing legitimate users. Of course, if I was unable to solve that captcha challenge, I wouldn't have been able to proceed to this page. Moving on, similar to what we saw in the application gateway WAF, we do have logging for these features. Here we are now within the front door logs, and I'm specifically searching for my front door web application firewall logs. We're able to see the events, their duration, when they begin. Of interest to us, particularly, is the one that I just did for captcha. And in this case, you'll see here my role name, which is the captcha request. This is my custom rule that I've configured with captcha. You'll see my host. We're also able to see the messages that come along with this. So you'll be able to see that captcha was issued due to a missing token, whether it was passed, whether it failed. In my case, you can see here that I successfully passed. Just also to mention, we do have metrics for this for captcha. And we also have, in the case of JavaScript, we have metrics for them both in application gateway WAF and Azure front door WAF. So these two tools really give us added arsenal when it comes to protecting our web application against bot attacks. So having taken a look at those features, next, what you're going to take a look at that recently came out is the application, it's the web application firewall in our application gateway for containers. So like we saw for application gateway for containers, this is our native layer 7 load balancer for workloads running in Kubernetes. So what it offers is the ability to load balance. And in addition to that, of course, now what came about is you have the ability to attach a WAF policy to an AGC. So that gives you protection to your Kubernetes workloads running in the backend. And with that protection, of course, you're able to ensure that only legitimate users are able to access your application, protect yourself against bot attacks, also protect yourself against OWASP-based attacks and vulnerabilities. So to showcase this, how it looks like, you can see here inside my resource group, I have here a Kubernetes cluster that is running, the AKS standard cluster. And within this cluster is where I have my web application. Of importance to us is the application gateway for containers. You can see here, we've named it ALB test. And this is now the actual entry point into my backend workload. It offers that ingress endpoint for us to enter our workloads running in the backend. So what you're going to do is take a look at how this has been set up and also see where now we're able to associate our web application firewall. So for us to begin off, for the AGC, you can see here, we'll start off with our front ends. And our front ends are our actual entry points. And the front end has an associated FQDN. So this FQDN leads now to an application that's in my Kubernetes cluster. We have two front ends, front end 1 and front end 2. And these are the actual applications associated to those FQDN. And then, so this is our front end. This is where now the user, the traffic will gain entry to. And then within now our application gateway for containers, what happened is that we now got a new feature. This is called the security policies. So the security policies, you can think of it as a container or as a wrapper within which now we attach our web application firewall. So within this security container, we are going to define our WAF. And in our case, we can see we have two security policy, security policy 1, security policy 2. And we have now the actual WAF associated with that security policy. So this is actually what happens on the Azure side of the application gateway for containers. If we want to attach our WAF policy to it, we'll need to have defined our security policy. But now this is just on the front end. For us to actually actualize and ensure that this policy is working and is actively blocking against attacks, we also need to attach what we call a web application firewall policy resource within our Kubernetes workloads. This is also what else we're also going to take, what next we're also going to take a look at. So I'm just quickly going to go switch over to my CLI. And here now we are within our Kubernetes workload. You can see I'd already run some few commands just to show us the nodes that are available and running. So like I mentioned, on the front end, on the AGC, on the portal side, you'll set up your front ends, and then you also set up your security policies and attach that WAF policy to it. So to start us off, what we now want to showcase is actually now what's happening within our cluster. So what I'm going to do, I'm going to run this command. This is the Kubernetes command for getting our gateways. So our gateways are actually associated with now our front end FQD ends. So I'm going to run this, and you can see now I'm looking for the gateways that are running within my cluster. I have two gateways, gateway 01 and gateway 02. And you can see here, this is the same FQDN that we saw in our AGC. So this means that this gateway is actually associated with my front end. So when a request comes in, hits my front end FQDN, it now becomes translated or is bound to a specific gateway. Within our gateway, you can think of gateway, if you're also familiar with the application gateway, as the actual gateway where a request will come in. And within our gateways, we'll have our listeners, and also we'll have our routes. And within our routes, we'll also have our paths. And this is important because now within our gateways and within our routes, this is where now we can also be able to attach our web application firewall policy. So we'll attach the firewall WAF policy either at the gateway level, that's at the global level, or at the route level. If we attach it at the gateway level, we have protection for that gateway as well as its listeners and the routes within that gateway. However, we can also be granular and attach it at the route level if we have specific routes running within our gateway. In our case, in our demo setup, we're also going to take a look at the routes that we have within this gateway. You can see here we have three different routes. In our setup, the first two routes are actually associated. The first two routes are actually associated with gateway 01, but we can also be able to get a specific details of each route just to confirm. With this, I'll just add the parameter -o, and then we can be able to see more details of our specific routes. So starting here, this is our first route. This is associated with gateway 02, and actually this is should be the, let me see if we can get its name, the demo route. So that's the name associated with gateway 02. We also have another route here. This route, this is on gateway 01, and this should actually be our HTTP route. So actually our HTTP route is associated with gateway 01, while demo route and GNX main route are associated with gateway 02. So within these routes, you can define paths. You can also define rules that now go to our backend services. So like I mentioned, this is just an overview of how now this routing will look like. And as an example within our demo, of importance is now we have the ability to attach a WAF policy to our gateway or to our route. In our case, we already had a WAF policy that is running unattached. And to see our WAF policy resource, we can be able to run this Kubernetes command. And here we can see we have actually two WAF policy. We have the WAF Gateway 01 policy and the WAF policy demo route. So what this means is in the first case, this WAF policy is attached to Gateway 1 and it's protecting all resources behind Gateway 1, while this second route, we've attached it to one of the routes within Gateway 02. We're also able to further see details, describe this web application firewall policy resource. For example, I can be able to see more details on this. So this is the web application firewall policy attached to my gateway. Of importance, once you have run this or done the association, is to ensure that the status is programmed, or rather the reason type is programmed and the status is true. So this will ensure that our deployment has been successful. And then to mention, in terms of the actual association, since you are in the Kubernetes world, it's not the same as we do within the Azure portal. You actually have to describe these components in a YAML file and apply this YAML file. So just to show you as an example, if you want to do an attachment, this is an example of a YAML file. So you'll need, let me make this larger, you'll need to define IAPA versions, you need to define your kind. For your WAF association, you need to give it a name. And also it needs to be within what we call a namespace that's associated with your gateway or your route. In our case, we wanted to attach our WAF policy to one of our routes, and this is what we did. So the kind will be route, I will give it a name, and of importance, we'll also give it the ID or the path of which it will be able to find that WAF policy and do the association. So once you've defined your YAML file, what you need to do is actually run a command to apply this YAML file. In my case, I'd already run this command. That's why it's already attached. I'll show you how it is actually done. So you're going to apply that WAF policy. In my case, you're seeing here, it remains unchanged because I'd already done this before. But we're also able to see specifically how that attachment looks like, what it's done, because you can be able to run another command to describe it, to see if it is actually deployed and if it has been programmed, which in our case, you can already see that this has been programmed and the status is true. So with this, we're able to apply security to our backend Kubernetes workloads. So with WAF, you'll get the same WAF images, you'll get the same protection that you do get if you're running a WAF in Application Gateway or in Azure Front Door. So having taken a look at that, we'll quickly jump at the logs for Application Gateway for Containers WAF. So logs are indeed available, so able to monitor events of what's happening in your GC, specifically to WAF. In my case here, you can see I already set this up. I already ran this KQL query to see the logs associated to my WAF in that AGC. And you can see here, similar to what you had seen in AFD WAF and Application Gateway WAF, we're able to see the events in terms of the roles, also able to see in terms of the matches, when did they occur, And specifically for within AGC, something you'll note here is when it comes to this column, which is the policy scope and the policy scope name. So like we mentioned, you can attach a WAF at the gateway level. Within the gateway, you'll have your listener and your routes. And this is where now we can be able to see, in our case, events related specifically. For example, the WAF that I've attached to my route can be able to see the policy scope as well as the policy scope name, which is at the route level, and the associated events that come with this. So again, we are able to monitor this. You have, of course, to set up diagnostic settings within your application gateway for containers, and then send logs to a log analytic workspace to be able to query and see events. So this is a great addition. This had also been asked from our customers, which now is in public preview, offers great protection, comprehensive protection for our web applications running in our Kubernetes workloads. Great. So having taken a look at that, last but not least, like we saw also one of the new features that came out. This has actually been out since last year, but went into general availability a few months back. This is security Copilot integration with Web Application Firewall. So like we saw also in the presentation, like Shabaz mentioned, we do have this integration. And what this enables us is to have that contextual awareness, as well as further enable us to do investigations when it comes to events related to Web Application Firewall. So what this integration does is it enables us to have integration with our WAF logs, both in Azure Front Door WAF and Application Gateway WAF, and be able to query these logs in a normal human readable language. Currently, this integration is in what we call the standalone security Copilot portal. So you can see here I've navigated to this portal. Within this portal, I'm now able to run several queries which I can be able to pass, investigate my WAF logs. The currently supported WAF skills in Security Copilot. This is the ability to investigate, to see my SQL injection attacks, cross-site scripting attacks, as well as top IP IPs that have been identified, as well as context on my threats. So you can see here I'd already run some commands. So for example, here I asked, was there any bot attack in my global WAF in the last 90 days? It's going to show us the steps that it took before it arrives at the answer. Then now here you're able to see the actual rule, the bot rule, the number of hits it had, as well as a summary of it. I also have the ability to export this to Excel, so I can also be able to do further analysis offline. I also asked it what was the top offending IP in regional WAF, regional WAF being my application gateway WAF. It's able to do the analysis and also be able to give me the results. So this, what it does definitely is that it enables us to do investigations easier, faster, and also, of course, when it comes to SOC operations, are extremely useful in doing deeper investigations. To set this up is pretty straightforward. You will need just to have integration of your log analytics workspace where you are sending your WAF logs. And once you've done that, you're able to use the WAF plugin, which is available. So if I go to my sources here, let's see my web application file plugin, it's enabled, and here we're already set up the log analytics workspace resource ID. Great. So with that, I know we've covered a lot, a couple of new features that have been released in the past 1 year, as well as recent releases. And I am going to end it here. and give it back to Emily.
Thanks so much. And it looks like all of our questions have been answered in the chat. So I think we are good to wrap up. So just wanted to say thank you again so much to Andrew and Shabaz for being our guests today and for sharing all of this great information with our community. Also, thank you so much to our Q&A team who helped us with answering all of those questions in the chat and for providing the resourceful information. To all the listeners still on the line, if you're someone who wishes to aid in the protection of the world from cyber threats and have a desire to have a say in shaping our strategies, blueprints, and recommendations, then we invite you to become part of our security community. Together, we can make a global impact. So join us at aka.ms/securitycommunity. This is also where you'll be notified about the upcoming webinars, events, and other announcements. For those of you who may have additional questions on the topic we just covered, or other product-related questions, please feel free to raise them on our Microsoft Tech community discussion space at aka.ms/ANS community. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.